Okay, so the stationary and mobile phase in both phases, in normal phase and also reverse phase partition chromatography. Okay, so in normal phase, the stationary phase is polar, highly polar, such as water or triethylene glycol supported on silica or alumina particles. Okay, so all these are polar stationary phase. Okay, so when your stationary phase is polar, the mobile phase must be in different polarity. So your mobile phase must have a relatively nonpolar solvent. Okay, so look at the words here, relatively nonpolar. It does not say it is nonpolar. So it is relatively nonpolar. What does it mean by that? It means that bila kita cakap pasal chromatography, kita tak boleh cakap yang ni polar, yang ni non-polar. Macam tu, kita kena relatively. Relative ni maksud apa? Dia comparative. Kita compare. So contohnya water. Okay, so water is very polar lah. Polar kan. So your mobile phase ni mesti yang relatively non-polar. Relatively non-polar ni macam mana? Contohnya methanol. Okay, propanol, yang lagi semua alkohol tu kan. Okay, boleh tak kita pakai hexane? Boleh juga. Okay, because hexane is very non-polar. So, dia relative, kita comparative. Contohnya, methanol as compared to water, methanol is non-polar as compared to water. However, when you compare methanol dengan hexane, methanol jadi polar, hexane jadi non-polar because it is comparative. Tengok apa yang kita bandingkan. Okay, so basic solvent for mobile phase, it must be relatively non-polar solvent, such as aliphatic hydrocarbons, contohnya hexane, aromatic hydrocarbons semua tu. Okay, so kita boleh pakai hydrocarbon sebab dia non-polar. And sometimes we may add solvents, alcohols, ethers and etc. This is the additional solvents. Kenapa kita kena tambah ni? Contohnya macam tadi kan, kita pakai silica gel. So this is polar. And then kita pakai hexane as our mobile phase because it is non-polar. However, we have bipolar analytes. Means that ada analytes yang polar, ada analytes yang non-polar. Okay, so what happens? For a polar analytes, okay, when you use hexane, hexane is very non-polar. When you have a polar analytes, what happen? Dia takkan, according to like Lyophilus principle, dia takkan ikutlah hexane sebab hexane is very non-polar. So what happen? It will stay longer. It will stay or it will retain in a very long period in stationary phase. So tak keluar. So your apa orang panggil tu, your analysis will be very long, your elution time will be very long. So kita tak nak juga. That is why we have additional solvents, and normally additional solvents are alcohols. Why? Untuk tarik keluar tadi. Contohnya methanol. Methanol CH3OH. So methanol ni dia ada part yang non-polar part here. Dia ada polar parts here. So your analytes tadi yang polar tu, dia dah lekat dekat stationary phase yang polar, tapi sebab dia pun ada polarity kat sini kan, polar part dekat methanol. So bila dah reach equilibrium semua dengan stationary phase, dia kan boleh attracted juga tu dengan methanol. Okay, so dia takkanlah stay very long time in stationary phase. So that is why we need to have additional solvents, okay, to speed up our analysis. And for reverse phase, your stationary phase is non-polar. Normally hydrocarbon, for example, octadicyl ni C18 maksudnya carbon dia ada 18. Octyl, okay, C8. Okay, and we also have dimethyl, 2 carbon lah. So, mobile phase, when your stationary phase is non-polar, mobile phase mesti relatively polar, such as water, methanol, acetonitrile. Salt is sometimes added. Why? Kenapa dia kena polar? Sebab dia kena lain lah, beza kan, so that your analyte can be partitioned between stationary phase and mobile phase. Kalau dua-dua sama, dia pun tak tahu nak pergi mana satu. Okay. So let's look at the principles of partition chromatography. So this is principles for partition HPLC. Okay, so in normal phase, so bila awak dapat je macam soalan ke apa, dia cakap normal phase or reverse phase, terus tulis supaya awak tak confuse. Stationary phase is polar. Mobile phase relatively non-polar. In reverse phase, stationary phase is non-polar. Your mobile phase is relatively polar. Okay, kena tulis supaya awak boleh tahu. Awak tak akan confuse. In a normal phase, the least polar compound or component is eluted first because it is the most soluble in the mobile phase. Increasing the polarity of the mobile phase has the effect of decreasing the elution time. Okay, so apa maksud dia? Least polar compound. Contohnya you have A, B, C. Ada ni. This one is the most polar. This is very polar. This is in between, and this is intermediate lah. Ini intermediate polarity. This is the least polar. Least polar ataupun the most non-polar among all this lah. Okay, so what happened? A, polar, stationary phase polar, so it will stay longer inside the column according to like dissolved light principle. It has high affinity towards stationary phase, stay longer inside the column, will be eluted last. So this one eluted last. Okay, retention time dia tinggi. But this one, it is least polar, paling non-polar among all this. So what happened? Stationary phase kita polar. So dia suka tak? Dia lekat, tapi lekat sekejap sahaja. So it will have the least attraction, least retention towards stationary phase. So it will be eluted first. Retention time dia rendah. Okay, if you increase the polarity of the mobile phase, it has the effect of decreasing the elution time. Okay, so tengok sini mobile phase kan non-polar. Okay, so tengok balik A tadi. A tadi akan stay longer inside the column, right? Okay, so contohnya dia keluar 20 minit baru keluar. Okay, so macam ni kita nak cepatkan, tak nak dia keluar 20 minit. Kita increase the polarity of ni non-polar tadi. Contohnya, okay, so in HPLC kita boleh ada binary, tertiary, or quaternary, mobile phase punya grade, composition. So contohnya kita letak hexane dengan methanol. Okay, ataupun methanol dengan water. Okay, so asal-asal kita water ni rendah lah. Okay, methanol tu tinggi. So kita lihat non-polar. Tapi bila dia keluar 20 minit lambat, so bila B dengan C ni dah keluar, okay, kita akan increase lah polarity. Maksud dia apa? Kita increase water pula. Contohnya kita start dengan water cuma 40% water, 60% methanol. Bila dah keluar B dengan C, kita naikkan 70% water, methanol 30%. So polarity increase. Ni kan, increase polarity. What happen? Retention time will be decrease. So contohnya daripada keluar 20 minutes, dia keluar lagi awal. 10 minutes, 15 minutes. Okay. So that is for normal phase. So for normal phase ya, kalau A, B, C, siapa yang keluar dulu? The least polar. So C akan keluar dulu. Okay. So if we have this, C akan keluar dulu, pick C, followed by yang intermediate B dengan A. A keluar paling lambat lah. And then so A keluar cepat sikit, we increase the elution time. So this C, the least polar, B, and also A. This is for what? Normal phase. Okay. What about reverse phase? So for reverse phase, dia terbalik pula. So stationary phase is non-polar, mobile phase is polar. So the most polar component will be eluted first. Sebab according to light dissolved light principle, dia tak suka kan, it has low attraction towards non-polar stationary phase. So most polar compounds appear first. So kalau tengok ni, yang mana akan keluar dulu? Of course A lah keluar dulu. So A will be eluted first, followed by B, and then finally C. C, the least polar will have high interaction towards non-polar stationary phase according to light dissolve light principle. Selalu kena ingat, kena cakap according to light dissolve light principle. So, dia akan keluar paling lambat. So, this is for reverse phase. Dia terbaliklah dengan normal phase. And increasing the mobile phase polarity will increase the elution time. Tengok yang ni kalau kita increase polarity, dia decrease retention time. Tapi ni kita increase polarity, dia lagi lambatlah nak keluar. So dia akan increase elution time. Okay. So so normal phase, in normal phase chromatography, low polarity mobile phase. Okay. Macam ni. Okay, medium polarity mobile phase lagi cepat keluar. Okay, however, in reverse phase chromatography, high polarity mobile phase, tapi medium polarity mobile phase. Okay, so solid polarities A yang paling polar as compared C is the least polar. Okay. Okay. So macam ni apik. So, tapi kalau kita increase polarity, what happen dekat normal phase, lagi lagi lambatlah keluar sebab dia lagi lagi suka stay dekat stationary phase tadi. Okay. So, tapi kalau kita increase the polarity untuk reverse phase, dia lagi cepat keluar. Okay. So normal phase versus reverse phase. Okay. So normal phase, stationary phase is polar. Reverse phase, stationary phase is non-polar. This is example. Yang ni kena tahu Dia dua je. Either dua je. Sama ada soalan bagi awak example ni, dia bagi nama ni, and then dia suruh awak tentukan dia non-polar, dia normal phase ke dia reverse phase. Ataupun sometimes dia tanya polarity of the stationary phase. Atau you are given this type. Dia cakap want to the analytes will be analyzed using normal phase chromatography. So question 1, give example of stationary phase that can be used. So kena bagi ni. So dari soal awak kena tahu dua-dua. Dia boleh tanya sama ada bagi ni, tanya ni, ataupun bagi types, tanya example. Mobile phase is relatively non-polar for normal phase. For reverse phase, it is relatively polar. So example this. Okay. And then kita pakai ni lah mixture of water ataupun organic solvents untuk alter dia punya polarity. Separation, these phases retain polar components in preference to non-polar components. Why? Because stationary phase is polar. According to, kena cakap lah, light dissolve light principle. So they stay longer lah, have high affinity. But for reverse phase, these phases retain non-polar components in preference to polar components. So non-polar will be eluted last. This one, polar eluted last. Eluent strength, macam mana kita nak bagi dia cepat keluar? Eluent strength ni apa maksud dia? Nak reduce retention time is increased by adding a more polar solvent. Example, acetone and diethyl ether. Tambah dekat mana? Tambah dekat sini. Hexane ni semua ni. Or in reverse phase, how eluent strength is increased is by adding a more non-polar solvent. It is called modifier. Yang ni kita tambah modifier supaya dia jadi non-polar. So, yang non-polar sample yang stay longer tadi akan keluar cepat sikit. Okay. So, the field typical applications of partition chromatographies are in pharmaceuticals. Typical mixtures are in antibiotics, sedative, steroids, and also analgesics. In biochemical, amino acids, protein, carbohydrates, lipids. Semua tu in food products, industrial chemical, pollutants, forensic science and clinical chemistry. So ini kena tahulah supaya bila dia tanya application awak boleh bagi tahu. So any of these. Itu partition chromatography.